30 degrees, okay? 30 degrees, and we have a box sitting on it. That box has a mass of 36 kilograms. All right, 36 kilograms. Okay, so the diagrams, most of you guys were not drawing the force diagrams, the free body diagrams that help understand that. The more you practice those, to me, it makes way more sense, okay? So, if this is on an incline, there's a force that we can't get away from. That is gravity, or the weight of the object, and it goes straight down. Weight. And we know the weight equals mass times gravity, okay? There's another force. The force, so what does gravity do? I should say, when you're on an incline, gravity does two things. Some of gravity pulls it down. If there were no gravity, the box would not slide down the ramp. That is called force parallel. Some of gravity pulls it into the ramp. Some parts of gravity make this object go into the ramp, and they contact. It's what makes the box squish into the ramp. Well, if the box is squishing into the ramp, force perpendicular, then the reaction is the ramp pushes on the box, and that is called force normal. How much force the box squishes into the ramp, that is force normal. If I have not done a good job saying that, I want to make sure you're back on track with that. That's what force normal is. The pushing of two surfaces together. Okay? So in this case, if I can find force perpendicular, then I know the force normal. So, when you're on an angle, when theta is greater than 0 degrees, when theta is some number not horizontal, force normal equals force perpendicular. And force perpendicular is this component. If this is 30, then I know this is 30, and that component is the cosine of theta times the weight, which is where I made the mistake earlier doing mass times gravity. So, for number 10, the force normal will equal force perpendicular, or will equal cosine of 30 degrees times the weight, which is mass times gravity, 36 times 9.8. All right? And somebody tell me what we got for that. I know a lot of people already got it. So what'd you get? 305 and some change. 305 and some change. I'm sure there's some extra decimals on there, okay? All right. Got to be able to get force normal. Ready? All right, in our notes. Friction. What is friction? Friction is simply a force that opposes the applied force. Friction is a force that acts when we try to move things, okay? So if I'm going in this direction, friction is going in the opposite direction. If I start pulling it, all of a sudden friction goes the other way. Friction always goes the opposite way. There are problems where you start with and friction is going to the left. And in the middle of the problem, friction could be going to the right because the box has moved the direction it's going. There's a couple different types of friction. The first type of friction is static friction. Static friction is the friction of a non-moving object. It is static, stationary. In football, I think about when I was playing football, and we used to have to hit the sled every day. And anybody that's ever hit a sled in football or something, you know, once you get it moving, you keep your feet moving. You don't stop. Because once you stop your feet, you can't get it going again. And the point is, static friction is stationary objects. And to get an object moving, you have to overcome static friction. You have to overcome that initial friction force. Now, once you got it moving, it's actually easier to keep moving. All right? Static friction is when we have no motion, and static friction is always opposite to the force applied. Okay? Let's try this. Is this moving? Is it trying to move? It's trying to move because gravity is pulling on it. That's called force parallel. Okay? It also is not moving, so it has what type of friction? Static friction. Now watch what happens if I keep pushing this up. Eventually static friction becomes, oh my gosh, it's like it's taped to it. I mean, we went from one extreme to the other. Jeez. What happens if we keep tilting it? Eventually it slides, it starts to move. So you go from static friction to kinetic friction. Kinetic friction is the friction of a moving object. Yep, heads up right here, it is less than static friction. Once you get that object moving, it's easier to keep it moving. And that is kinetic friction. So we had our little examples here, and they didn't work out real well. But I think you get the point. Can you tilt an object and it not slide? Yes, if it has enough static friction. Now the problem is once it starts moving, sometimes it just keeps right on moving because kinetic friction is less than static friction. Please make a note. The net external force is difference between applied and kinetic. So when you have kinetic friction, the net force would be different than when you have static friction. Why is this not sliding? Because friction. Since it's not sliding, it's a certain type of friction called static friction. Now, static friction is less than kinetic friction. This has got a lot of static friction. How much static friction does this have? Not much. Now, why is there a difference between those two frictions? Now, this is the key point I want to make. There's two things that affect friction. We might be getting a little ahead of ourselves. Two things that affect friction. Why does this not have a lot of friction? Weight. For example, could I increase friction of Batman? Yeah, let's stick this on top of it. Does he slide now? Not as easy, right? What's another thing I could do to Batman? I could change the surface. Two things affect friction. Two things affect friction. One, the weight of an object. Two, the one that you know of before that you always thought of, the surface of the object. You know why this slides so well? It's because the surface is slick. But this has little grip pads on it. And they don't slide very well. Two things affect friction. Okay, weight, anybody. Why were we studying force normal so much? What controls friction? Not actually the weight, but the force normal. The push between the two surfaces. If I push this, another way to add friction. If this is sliding down, I don't need it to weigh more. What if I just push it? I didn't just change the weight. What did I change? Come on, force normal. What controls friction? Not the weight, but the force normal. Now, what controls force normal? The weight. And me pushing on it. Oh, I just made force normal go up, and it doesn't slide anymore. I added a force of friction. I increased the friction. Now, if I don't want to push on this, I could get a different surface type. Okay? Two things that control friction. Friction is caused by microscopic contact forces, electrostatic forces, and these are called adhesion. Okay? Not really our main point, but that is true. Electrostatic forces, the forces between little molecules that are interacting with each other. Together more, if I push those surfaces together more, the force normal goes up, the friction goes up. Important to know force normal because that is the key component, one of the key components to force of friction. Ready? Force of friction is proportional to normal force. More normal force, more friction. Check? So how would you decrease friction? Pull up on the object a little bit. Like if you'll lift up, then I'll push. If you lift up a little bit, I can push this box because you're decreasing the amount of force normal, which decreases the amount of friction. Friction depends on the surfaces in contact, friction occurs on the microscopic level between different surfaces. That's called the coefficient of friction. Ding, ding, ding. New information. Information number one. Information number one. Friction depends on the weight. Not really the weight, but the force normal. Because I don't have to change the weight of an object. I could just push on it and make it stick. Or I could lift it up a little bit and it start to slide. Number two, friction depends on the surface. Yep. Now, there is a number that represents the surface, and it is called the coefficient of friction. There is a number that represents the surface. It's called the coefficient of friction. It is given by symbol mu, this funny looking U. Okay? We have one for kinetic friction and one for static friction. You don't really have to worry about the differences in those except for you use the static when it's at rest and you use the kinetic when it's moving. As simple as that. It's not 5 different formulas. It's just static, kinetic. Okay? Using the above, we build a formula for friction. So, guys, all of this running around and jumping and hollering, and well, I didn't do any jumping, but all of this is to say, come on, like, name 2 things that affect friction. All right, not the weight, not the mass. You were right with weight. It's really not the weight. It's the force normal. Now, why do we care about studying force normal so much? Force normal. Because it has to tell me the force of friction. Where do we usually get the force normal from? It always has something to do with the weight. The weight of the object changes the force normal, which changes the friction. If it's not the force normal, it's the surface type or surface area. And that is called mu. So mu is the coefficient of friction. And it represents surface, type, and area. Check mark? All right, so in our notes, there's a table in your book that we don't use anymore. Here's what I want you to write. Ice. Ice. Mu S, mu K. I don't know what they are. We could look them up. There's some number. But do you think ice is going to have a high coefficient of friction or a low coefficient of friction? A low. It's going to be something like 0.001. The point is, it's a low number. That's all I mean, eventually we're going to look these up. But for now, you just know that ice would be low. What about sandpaper? Yeah, it's going to be high. It's not going to be like 100 high. It's still going to be a decimal, but it's going to be like 0.09. I don't know. It's much higher than the other one, okay? In terms of coefficients of frictions, it's higher than the others. So as the number goes up, as the coefficient of friction goes up, the amount of friction would also go up. Okay? All right. Air resistance is a form of friction. We've actually already discussed this, but we'll take a minute to write it. Force of air is friction. Where does it come from? Gravity's trying to pull an object down. Air is trying to push the object up. The longer gravity acts on the object, the greater the friction becomes. Eventually, those two objects will reach equilibrium. The object falls, but it doesn't fall any faster. That is called terminal velocity. And we've already discussed the basics of terminal velocity.